symbols. Let's do that first. We're calculating R for the correlation coefficient. R, lowercase. Okay. Y-intercept, lowercase a. Slope, lowercase b. S subscript b. Predicted y is 5. And then there's give me. It's the only symbols we have.
What does the fourth one say?
What?
What is the fourth one?
Fourth one?
Yeah.
The standard error of estimate.
Okay.
So, did you, this says 37 points and 15 multiple choice questions, did you take one away?
That's what it is.
Okay, so
Yeah.
just change what it says on the paper?
Yeah,
Okay. Thank you.
you're almost welcome.
Only honest.
On a SR?
S subscript E.
Yeah, that's right. You guys are
I'm making this up.
making what up?
Scatter plots. We did this last time, but I think you will get the gist. Basically, there's going to be some scatter plots, and I'm going to ask you to draw the best fit line. It's the correlation high or low, medium,
Okay. That's, this stuff.
or is it positive or negative?
This stuff?
So what about this one? Best fit line is going to be like that, right?
It's positive and high.
We got a positive and probably high correlation. The dots are really close.
Negative and low.
That one's going to be is it a zero.
Well, what is this, why does this say negative and low? That one was an oval.
Which one?
That was a negative and low that I have in my notes. So that's what I'm asking.
And this is basically negative, very freaking high because it's almost perfect, right?
So,
Candy cane effect, you kind of have to look at it, but the line has to best represent those. And that's going to be negative and low. Kind of the idea.
That one always confused me. Can you like elaborate on why that's?
but this is supposed, right.
Of course, we have that. The best fit line has to represent the distance from all of those, so that's going to, there to there, it's going to be the best it can do. And notice, as I pointed out, you're running the wrong analysis on this, because it's actually curvy or linear. And if we added 2 others in there, remember what this one looks like when you just have outliers?
Yeah.
That has to go positive. But if you got rid of those, notice it's going to look like that. It'll be basically 0. So in this correlation business, if you don't look at the scatter plots, it's really easy to mess stuff up. Yes,
Can you draw that if it was positive?
this one?
Yeah.
So, the one on the bottom and the one in the middle on that side, those are both negative and low.
Yeah.
It's just drawn.
Hey, it was Sydney. She said you do, so I just made it bigger.
Oh, okay.
Because, she's, I don't know, What do you want? You have a question? May I have another question?
Yeah.
Okay. Go ahead.
So for the correlation of like high and low, what is the median?
Yeah, you can, this would be probably something, I'm not gonna tell you on the test, but notice. Still positive, if they get across this, will be more median.
Okay.
So
Not
as
too
they,
far apart, but it's not close enough to be high.
you know, and after a while, if you see enough of these and run enough of them, you go, oh, that's probably an R equal 0.41, and this kind of just know what it is. It's done.
Can you say median?
Yep.
Is the outlier one going to be on the exam?
Probably on yours, yeah.
What did you say that?
You're gonna have 46 of those to do.
The last one he drew?
Yes.
He said it's positive
I see
and
the
median,
first one.
and
What
we
was
see
the
there's
second
controls
one?
sometimes
This
you have
one?
to do the
Positive
higher low.
zero?
And it's gonna be zero,
You just said
R
higher
zero.
low.
R,
Yeah, it's not gonna be like,
Notice when a zero
Um,
correlation, it's just the
he's
SpongeBob
explaining
thing.
again.
So it's like everywhere.
Yeah,
Yeah.
there's no.
So this means no matter where you are on this, you could be equally anywhere.
So
There's
he
no
was saying
relationship.
high and low. He sees
In the
it
candy
like-
cane, are those positive or negative?
The difference is.
This,
So he was
this
just
one's
asking what it would
negative,
look
this
like.
one will be positive. I kinda drew the line a little poorly, but yeah.
That's not.
Just kinda
So
eyeball,
he's just
because
wanting to know, is it going
the
in
idea
the positive
is
direction
that
or is it
these
higher
dots
or
have
low?
to be, represent. the
Higher or
distance
low
from
is
here,
about
so
the
you
accuracy.
Kinda split the difference.
So like, these dots are really close, so it's pretty high. And this is high and this one's not really anything else, so he's low. So if it was like, they were kind of everywhere, but it was still going up, that's really low because they're not very
So we get
accurate.
rid of that.
So the one he just drew, even though it's positive, it's low accuracy because they're really far away from him.
Tell y'all that,
You
And
saw
precision
those
nine.
in multiple choice, and, but, I could give you those, but which one of those represents the highest correlation?
It's negative 0.99.
That'd be the highest, which one's the lowest?
Negative 0.18.
So remember, it has nothing to do with the sign. Magnitude of the relationship just has, the larger, the closer it's to one, the stronger the relationship. Positive, negative just means how you're gonna interpret it. So basically, I have a question, and I have like 4 of those, and I just ask you to pick the ones that, since I choked to death, represents the correct rank order. So and that's what, if we ranked it, it would be 0.99, positive 0.89, positive 0.2, and a negative 0.18. Highest, next to highest, 0. Ah, what is this? Ready for the second multiple choice question? Biology, I haven't seen you in a long time. It's like you look a little under the weather. Okay. So you hate me still? I will. The best fit line, the regression line, what defines it? What is on those, that best fit line? Something we calculate,
such a what, oh, yeah.
predicted Y's. So every time you calculate one, it's always gonna be on that friggin' regression line.
Say that again, what?
The regression line, what defines that? And this is what you'll do on the open book test, you have to actually use that little formula, and so when you use that formula, everyone will be on that regression line, no matter what. It's always on our best prediction, and then the rest is slop. So, the answer, I know you like these, the answer to number 2 is B.
Okay.
Okay? I just, it's okay.
The answer to number 2 is
Ready for the third one? Whitney? Okay. It says, as the standard error of estimate increases, what happens to R? Standard error of estimates, how far the dots are from the regression line. So if that increases, right, R goes, what, we do sign language now? Is that how we want to communicate?
well, I missed.
So as error increases, correlation's got to decrease.
Okay. But I
So here we got a lot of standard error, a lot of variability. not much variability, so R is gonna be higher here than there. It's kind of a visual thing. Granted, y'all are like really kicked this because I had 2 blind students, and they got A's on this class, and I'm sitting there feel like I'm doing air talking. It's a dot skip. What is so I don't know. Ready for number 4, Cole?
Sure.
Okay, it says R values can range between what and what? What are the magnitude of R? -1 and positive. What, y'all doing this in 2-part harmony?
Yeah.
Okay, fine. So, and also, remember I told you that there will be one question that says something to the effect that they found a correlation of positive 1.32 between something, and then you read it, and if you interpret that, I'm gonna run you with a truck. Because the answer should be something like, they need to hire a new statistician. You can get a correlation greater than 1. Biology, how's it going now? Kind of like worried about her that she's, she's thinking of, fig preserves. That was my animal and my biology that we had to dissect. We had a name fig preserves. The cadaver that I had in PE Med Center was also named fig preserves. They didn't like me to call it fig preserves. Okay, here's the hard one. Standard error of estimate. What is it? It is variability about the regression line, right? But also it's the, think of it as the average deviation about the regression line. So we just slide it up and down.
It's the average deviation.
Yep, about the regression line.
That's not what I have written down.
Yep. So notice, I'm gonna do this.
From the regression?
If those were the scatter points,
Did he say average deviation from the average? About.
Alright.
so each one of those has a predicted Y. So if you were subtracting the predicted Y from the actual Y, and took an average of that, that's what standard error kind of represent. On the average, how far are those dots deviated from the regression line? Ready for the next one? If there's no linear relationship, what will R equal? Who said that? Y'all doing 2-part harmony crap again?
Wait, what was the question?
If there's no linear relationship between X and Y, R will be
0.
0. So null hypothesis regarding correlation is what?
Let's do it again.
No relationship, but the correlation is also going to be 0.
Wait.
One more time.
Okay? And then there are 2 questions talking about a positive correlation means. And so you'll read the options, and basically it just means as one thing increases, the other one increases. Negative correlation just means as X decreases or increases, Y will decrease. I think you can probably get those. What is the slope? Basically, the slope's telling you for every increase in X, it's telling you how much Y will increase.
Okay. Yeah. Is that what he said?
Is that one? So, if correlation was positive between years of education and IQ, that would mean the higher number of years you went to college, the higher your IQ. And if slope was equal to 5, and this was measured in years, that would mean for every year you went to school, your IQ would increase by 5 points.
Yeah.
Is that a question or a choice?
Yeah, well, it's kind of the interpretation of R. It's in a multiple choice, so you know what that is. Also, on the open book, you're going to have to tell me what slope means in relation to the problem. We already have the thing about the weakest correlation. The closer it is to 0, the weaker the relationship.
Wait, what? Closer is to 0.
Which one's the weakest relationship?
USPC.
Mm-hmm.
The one that's closest to 0. Yeah.
Yeah,
I
the
heard
one
you,
when
I
it's
just-
closer to 0, the weaker the relationship.
It just took me a second to process it.
Yeah.
I'm sorry.
That's the open book part, or the closed book part. So the closed book is only on correlation and regression.
Wait,
No.
what was your definition of that again?
As
That would be really fun.
X increases, it tells you how much Y increases if it's positive. If it's negative, it means for every increase in an X, Y will decrease. So notice if this was negative, that would mean for every year you went to school, your IQ is going to decrease by 5 points.
Could it also be for each amount that X decreases?
Say that again.
For every amount that X decreases?
For every single unit.
Yeah,
Yep.
every one.
Yep.
Okay.
Yep, that's what that means.
All right.
Everybody kind of got that? Yes, no?
Yes.
The exciting open book. There is one correlation problem, and it's going to be worth between 25 and 30 points. So you got basically you have two X and Y. And so you're going to fill out your sheet and enter it in the computer. It's going to be 2 columns. And you just follow that roadmap, analyze, correlate, analyze, regression, and you'll have all the data that you need. If you look at the handout that I gave you, I circled everything you need, and of course it's going to say, write the means and standard deviations for X and Y. I'm going to ask you to hand draw a scatter plot. I want to see you plot those so you know what this really means.
We get 2 hours for this.
And then write it in the correct format. That should almost be a no think thing now, but for R. Degrees of freedom is in there. What you calculated, comma, probability. You can guess what I'm going to ask you next. Write an interpretation.
Yeah.
And so you're going to say if it's positive, you're going to say for there as so-and-so increases, so does whatever it is, the other variable. Lane, you got that? And then it'll say, what would you predict? I'm going to give you an X value, and you're going to look at your regression output, and you're going to get, remember that in the printout is A is the constant, and B is the slope. And so you plug that in, and you'll have the prediction. much error is in your prediction. You're gonna look at your printout and read the standard error of estimate. And I want you to tell me what that means. So notice, predicted Y is going to be your best guess. And this is going to tell you plus or minus 1 how much it's going to be off. So for a given X, here's the predicted Y. This is plus and minus that like standard deviation. And as you probably still remember, for this prediction, 68% of them are going to fall plus and minus that value. That's good. You getting feeling any better?
Well,
Not that I really care.
yeah.
Whitney, you're going to be able to do that?
Yeah, what kind of? Like,
Desiree, you kind of got your Christmas sweater happening today.
it's gonna be, yeah.
I'm sorry?
I'm not, I'm sorry.
No.
You're understanding. No, it's just. Understanding.
So, there will be an analysis of variance.
It comes to the same thing.
So you're gonna have one of those problems. So, everybody did, as I mentioned last time, pretty good on that last exam for that. So as usual, you're gonna do your dummy codes, analyze, and write it in the correct format and interpret. Yes?
Wait, this is probably a stupid question. So for every, every exam, you're gonna have a different section of multiple choice and symbols and all that again?
Yeah.
For every,
The
just like we did.
open book, or the closed book is just those 14 multiple choice and symbols following about it. Open book, and I've rank ordered them.
Yeah,
So
okay.
in terms of how much points, so the first part is the correlation, and there'll be somebody who'll run a friggin' t-test on that, it's like, God, why are you doing that? But, that's the one you gotta do, and I just went through every question that you're gonna have regarding that. It's just exactly like the homework, so, and I have interpretation, just, all you gotta do is just practice it, I mean, you can do that. And then you have the ANOVA stuff, so you're gonna run that, and then basically, the only thing you're gonna do in that is give me the means and standard deviations. Give me the summary table, just like the last exam, and write it in the correct format and interpret it. Okay? And you'll have to calculate an effect size. So just to repeat the last one, but it's not worth as much. Then there's another problem. As you might guess, it's going to be a t-test. One thing you got to figure out is which t-test it is. Independent t-test or the paired samples. I'll give you a hint. Remember, if it's two distinct groups, it's an independent t-test. One group tested twice, it's going to be the paired samples. And as usual, give me the means and standard deviations, write it in the correct format, and interpret it. And calculate an effect size and interpret it.
So how many problems do we do?
3. Well, there's 3. Well, everything is run it, means and standard deviations, write it in the correct format, and interpret it.
Oh, but that last one's gonna be an either or.
Yeah, I'm not telling you which one it is, but it's going to be a t-test of some sort. You just got to pick which one it is.
Stop trying to cheat.
So I'm not going to kill you. I mean, it's not worth that many points, but you don't want to like screw it up. Well, some people might. You're kind of those kind of individuals who like self-punishment. I mean, the whole problem on the t-test is worth 10 points. So you can blow it off. And as usual, and I'm probably going to do this, but there are 3 scenarios, just like before. State the null hypothesis. Which statistical test will you run? One-tailed or two-tailed? And then there are, looks like 5 multiple choice questions.
Yes.
2 of them have to do with a type 1 and type 2 error. I just want you to know, it's important in stats to know what those are. Remember the mean, median, and mode? Which one of those is affected the most by extreme score, an extreme score? Mean. Which one is least? So it's gonna be one of those 2 answers, don't pick anything else. When we did Z-scores, yeah,
What was the least again? I missed it.
median.
Median.
Medians don't lie.
Yeah, they're like always in.
Median is God's gift. Why we don't report those in research, I don't know, because you would figure out really quickly there were problems. So, Z-scores, they always have a mean of 0 and a standard deviation of 1. Whether you know it or not, somewhere down the line, you're gonna see a printout and somebody's gonna have that in the real world. And really they call it standardized, we standardize it. We convert everything to a Z-score, so it allows us to compare apples and oranges. So regardless of what the mean is, it's all, for the Z-scores, it's always gonna be 0, standard deviation is gonna be 1. And you can probably pick that. Hopefully you know what the independent, dependent variable is. And then there are 2 bonus questions. So, our test is Tuesday or Thursday?
Yes, it's Tuesday.
Which is it?
Tuesday.
Good. So, yeah. So I would practice it, just see if you could run those, collect your notes. So everything is kind of ritualized in this business. Main thing is what statistical test to use when, run it, write it in the correct format and interpret it. Yeah.
Are we gonna have to do any like manual problems, like we started out with the one,
Nope. I could, but no.
Thank you.
Yeah.
Is it a regular time?
It's I think it's 11 to 1. No, sorry, sorry.
I have another final at that time.
No, sorry. It's 2 to, I guess,
It's 1, 3, 2.
I think it's up
okay, what is it?
1 weird.
Okay, it's in the syllabus, but basically, she's correct, it's 1:15 and to 3:15, right?
So it's at 1:15.
This is, that's a really weird, awkward time. Like,
So they have to schedule, since everybody's 2 hours, they have to like juggle it and make it happen. I suggest coming in here, and as soon as you get here, turn the computer on, so it'll be ready when you get ready for part 2. Really, practice it, just make sure you're comfortable with entering the data. Just remember the ANOVA, you gotta do the dummy codes. T-test, it's an independent T-test, you still gotta do dummy codes. Okay. Yeah.
I have a question about the ANOVA, about the interpretation. Do
Yep.
you have like any advice on how to get them straight, like how to get them all in there and comparing each other,
You mean get it in the computer or interpreting the results?
interpreting?
Interpreting results, oh yeah, it's easy. I would look at the graph. Because you're gonna plot it and I would look at it, so basically. So as soon as you look, you have to look at all possible comparisons. This is group 1, 2, and 3, so is there a difference between those 2? Probably is. This one is significantly better than this. 1, that's a 3. 1 versus 3, probably not significant. And so you have to look at the probabilities in the Tukey's. So again, if it's less than 0.05, then there's a significant difference. So like if this came out to be P equals 0.33, they're not significantly different, even though this is a little higher. Some people like to interpret that, but you have to say no significant differences. And then of course, 2 versus 3, 2 is significantly better than this, also better than this.
So you're only saying it's significant and compare them if there is significance and one is higher
Yeah.
than the other.
But notice, if you're telling somebody what happened, you have to tell all possible combinations.
Of just significance, not if they're higher.
Well, you have to say what's not significant.
Okay.
So this is important. Notice if you got this, probably nothing is significant. So overall, you found no significant effect anywhere. F would be 0. When you get the ANOVA, if it's significant, the F is significant, it only means at least 2 of those is significant. And you could have this.
So between
This
like,
one's significantly better than that, this one's better than that, this one is better than that.
okay. So between like 1 and 3, you would say, like let's say if they weren't significant, you say they're not significant, but 1 is still better than 3.
So it's just, you assume they're equal.
Okay.
Sometimes it's close. Now technically later on, we don't teach that unfortunately, but I would still be calculating effect sizes on that. Still, the magnitude of the effect could be very, very important. The significance thing is determined by how big your sample size is. So eventually, if you have a large enough sample size, anything will be significant. You can even find like IQ, 102 versus 3 and 102 versus 7. If you got a large enough sample size, those would be significantly different. So pretty much in the research world, there's clinical significance, there's functional differences, and then usually fall into some meaningful. If that was significant, it would be meaningful at all. But you just had a large sample size.
So,
What?
nothing. I was just trying to complain, that's what I do.
Yeah, well, part of that is, that's why I tell you about this, is that stats is everywhere and things happen. And even the people, my colleagues and people have major research grants, sometimes they don't know what's going on. Main thing is that the type 2 error, maybe it's an important effect, but you didn't get something less than 0.05, so you're gonna say there's no significant differences. But it's a very important effect. Could save somebody's life, like the aspirin study that I brought up. The effect size on that's like 0.09.